Hey, Vlad here, devinsideU.com. Welcome to another video. In the previous video, we pretty much finished integrating the maps into our homegrown collections library by showing that maps are foldable creatures. And in the videos before that, we implemented some rudimentary methods on maps like add or remove. And today, for the first time, we're going to implement some really cool methods on maps that are very, very specific to them. As always, we're in the Ubuntu virtual machine and we're running Sublime Text, the editor of my choosing. This time it's maximized, and we're also running a plugin called Terminus, which emulates an entire terminal for us, which runs SBT, which reruns the test every time we save the file. As you might notice, my background is different. As I mentioned a few videos ago, I'm currently traveling. Right now I am in the capital of Brazil. Like this video if you love Brazil for any reason whatsoever. This means that I'm on a laptop with a lower resolution than usual. Usually I am on a 1440p monitor, and right now the laptop has a full HD screen, but it's actually not such a bad thing because I think it's gonna even look sharper on smaller screens, so I think it's even better like this. I'm trying to save some space wherever I can. I reduced the font size to 20, and also from now on we're gonna send Sublime into full screen, and also I enabled the word wrap globally, which means that you will always be able to see all the code no matter how small the window is, and this will give us some extra space because there will be no horizontal scroll bars that they're taking this space. By the way, you might not care about the next piece, but usually I'm recording on two monitors. I'm recording one monitor, and there is another monitor on the right of me where I run an extra Sublime instance with the script with all my notes for the video. But right now I'm traveling, so I have only my laptop. So what I did was I bought an Android tablet, and I'm using a really fancy application called spacedesk, which allows me to use the tablet as the second screen, which is kind of cool. I'm not really sure if it works with an iPad, but so far it works with an Android. And once a developer inside me found out about this really fancy tool, I was happy like a little girl who found a unicorn. All right, let's finally start writing some code. Sometimes we have some refactoring in the beginning of the video. This time it's going to be really, really fast. So I'm just going to remove this comment with domain, and I'm also going to go to map suite, and I'm going to go to line 9, and there's also another comment over here, so I'm just going to remove it like that. And also there's another comment at line 665 over here. This is what I'm going to do, and that is pretty much it. So I'm going to open another instance over here, and I'm just going to say git commit -am. This is video 22, and I'm just going to say refactoring. And that is all. I'm going to push it by the end of the video. So the first method that we're going to add today is called withDefault, and the idea is that you have a map and you call withDefault and you give it the default, and then once somebody asks for the key, and if the key is not there, you're just going to simply get the default out, and the default in the beginning is going to be a function. So dependent on the key, which does not exist, you can give out different defaults as a result. All right, so we're going to go to the bottom over here. This is our last test. So we're going to add a test for withDefault, and it's going to be a simple one. So we're going to say withDefault should return a default value dependent on the key for all keys without values. Right. So as always, we're starting with the bad test because we're doing some sort of TDD, and in TDD you never should go for the gold. Right. So okay. So we're going to have this function which is going to be called default value of. And it's going to get some key, which is going to be an integer, and it's going to return a string back. Right, so it will just take the key, add a 1 to it, and convert it to a string, because we're going to have a map of ints to strings, right? So we're going to have a map, and it's going to be an empty map, right? Because in this case, we're just trying, the bad case. So we're going to have map.empty, and the keys are going to be ints, and the values are going to be strings. Okay. So and now we're going to call withDefault, which doesn't exist yet, and we're going to pass in the default value of method, and then the edit extension is going to kick in and convert it into a functional literal. Okay, and now we're going to simulate, Scala check kind of thing. So we're going to not write basically one test. We're going to write 10 tests, right? So we're going to go from 0 to 9. I'm going to say for each, and we're going to ignore this number. What we're going to do instead is we're going to go and we're going to say random key. We're going to generate a random key by calling a function called randomInt, and randomInt is going to reside in our package object. So remember in our reveal in sidebar. So in our test package object, we have a bunch of helper methods like random string, for example, random consultant, and so on. So we're just going to add another one called randomInt. right? Which is going to go to Scala util dot random, oops, random. Next, and like this. And because we're using random twice already, let's just import it over here. Import Scala util dot random. Let's go down over here. So now we don't need that, like this, and that, like that. Okay, so now we have the random int, and oh, it should return int, obviously. All right, so let's go to map suite and finish writing our test. So we have the random key. I didn't save the file yet, so it's fine. So we're gonna call the map now with this random key. Right, and this is an empty map, right? So nothing should come back, but we're using this withDefault, right? So it should be some default value of random key, right? So we're using this function again, right? It will just add the key, add 1 to this randomly generated integer, and it should come back like this. Okay, so if I set the file now, it's going to complain because we don't even have the withDefault method. So now we're going to add the signature. Maybe we should also do that and put the map suite on the left and the map on the right. We can actually close the package object. Okay, so let's go down and okay, so this is our companion object over here. So this is our class. So we're going to add a final def withDefault, and now because the value is going to be in the covariant position, and we're going to have to do this covariance dance like this. Okay, and let me actually create some more space like that. All right, so we're going to have our default, which is a function that takes a key and produces a super value. And this entire thing is going to produce another map, right? Because everything is immutable with a key and super value equals something something. Whoops, I wanted question marks. Come on, question marks. There we go. Okay, so now at least it should compile, but the test should obviously fail because we're throwing an exception over here. Right, and in fact, maybe we should also switch to running only the map tests. Okay, test only, test. Come on, test only. Homegrown. Is it not? Where is it? Oh, it's called. It's in user. Okay, so user map suite. There we go. All right. So now one test failed, and it throws the not implemented error. All right. So the implementation is going to pretty much look like this. So it's going to just create another map. Right, and it's gonna keep the keys. The keys are gonna be the same, and like this. And what it will do, it will just change the value of function, right? So the value of, if you remember, this is how our map looks like. It's just a set of keys and a function, which is just sort of like a partial function, but we implemented it using a total function. Okay, so let's go back again over here. So we're just going to change the value of function, right? If it was an actual partial function from Scala, we could use the or-else method, but we're using a total function. So instead, we're going to use the or-else method on option. So what we're going to do here is we're going to produce a completely another function, which takes a key, right, goes down like this. And by the way, my voice is kind of gone. I'm kind of sick. I've been sick for like a week. I tried not to record for a while, but it kind of didn't help. All right, so what we're going to do is we're going to say, okay, so let's try to get the value of the key, right? And if it doesn't exist, we're just going to do or else, and we're going to produce a sum by calling the default and passing the key in as a parameter. And this is pretty much the entire implementation. Usually in TDD, you would just, write the part of the implementation that only covers the test. But I want to save some time, so we're just going to have that. Okay. Why did it inline it like that? I sort of wanted to inline it like that. It's not going to do that for me? No, it's not. All right, so I actually don't like that. I'm going to do a format of here and format on over here like that. And I want to manually inline it, whoops, in the other way, exactly how I want it to have. All right, there we go. So what we're going to do now is we're going to add a few more tests, right? Because we're very, very test driven. Where is it? Over here. Okay, so this task is going to say, withDefault should not call the function unless necessary, right? So we're going to have a key, which is going to be a random int, and we're going to have a value, which is a random string like this, and we're going to have a map, which is a map of, let me scroll down a little bit, a map of one tuple, right? So there's a key value, okay? And we're going to say, whoops, we're going to say withDefault like this, and we're going to say, okay, whatever comes in, throw an exception, right? Throw an exception, throw an error like this, and this should not be thrown like this, right? And Scala test provides us with this cool looking, no exception, should be thrown by map of key. So we're trying to retrieve the key, but the key is actually there, and therefore it's not going to throw this exception because it's just not going to go there. Okay, so let's save that, and also let's add another line over here. I'm going to say, okay, if I'm getting the key, then the value should be this, right? So this is basically the other part of the test. Okay, so the next thing that we're going to do is we're going to add another method called withDefault value, and withDefault value is going to return always the same default if the key is missing, right? So this one, you know, it can pattern match on the key, for example, right, and return different value, or what we are doing, you know, dependent on the key over here, we're just adding one, so there's a different default every time. This one is just going to be a sort of almost like a helper function. All right, so we're going to write a test for it. We're going to say withDefault value should return a default value for all keys without values. Okay, let me scroll down a little bit like that. Okay, so the test is going to look like this. So we're just going to go and say val default value equals default value, and I'm going to create a map, and it's going to be an empty map like that, empty and string, and we're going to call withDefault value. Right, that doesn't exist yet. We're going to pass in the default value, and then we're going to do a similar thing as we did at you know, as we did above. You know, it was a 0 to 9 thing. So we're going to go 0 to 9. Whoops, press no. Okay, so 0 to 9. We're going to go for each, and again, we're going to ignore that thing. And this test is actually going to be a bit smaller because it's, you know, it's simpler. So we're just going to go say a random int, which is going to, you know, we're going to use a random int as a key. Should be, and it's always the same default value, like this. All right, so it doesn't exist obviously, so it's not going to compile. So let's go over here like that, scroll down over here and add it. All right, so it's going to be a final def withDefault value, the same covariance stance over here, value. Okay, it's going to get the default value, which is going to be a type super value. It's going to produce a map of key and super value like this, and all it will do is it will just call withDefault, right? So we'll just call withDefault. It basically will convert this default value into a function like this, default value. And because I like it to be readable top to bottom, I'm going to put it above, right? So we're going to have withDefault value calls withDefault, which is right over here, so you can read it top to bottom. All right, there we go. It should be green in just a few seconds. There we go. All right, so the next thing that we're going to do is we're going to add another test for the withDefault value, and we're going to make sure that the parameter that we're passing into should be a by name parameter. So the withDefault value should use a by name parameter for their default. All right, because we don't want the default to be evaluated if it's not necessary, right? So the way you do this is you create this cold Boolean, right? And then by the end of the test, you make sure that it's in the state that you want it to be. So we're going to have a lazy val default value, right? And it's a lazy val because we don't want to evaluate it. So once it's evaluated, the cold is going to be set to true, and then you know, we have to return a string, right? So we're going to have default value over here, and then by the end of the test, we're going to make sure that the default, that, you know, that the cold variable is still remains false, right? So by the end of the test, we're going to say, okay, cold should be false. Okay, so let's write the middle of the test, so to say. So let's go over here and say, okay, so let's have a key, and it's going to be a random key, random key like this, and it's going to be a value, and it's going to be a random string, and value should not be default value, just, you know, just to be sure. All right, so now we're going to create our map. It's going to be map key value, okay, and it's going to be withDefault value of default value. Okay, so now what we're going to do is we're going to call, you know, we have to actually act on our map. So we're going to ask it for the key, and this key exists, right? So it's going to say should be some value, and therefore the default value, this lazy val, should not be evaluated, right? So if I did everything right, then the test should be red. And what's happening? Postfix, blah blah. Oh, hold up. There we go, like this. It's not what I wanted. There we go. All right, reassignment to a val. Okay, I'm just used to, to writing in such a way. It has to be a var, obviously, right? Because we're setting it to a different value. Okay, random key doesn't exist. What's happening? I meant random int, right? We're generating an integer. There we go. All right, so now it should be red. It says true was not equal to false. And all we need to do is we need to convert into a binary parameter over here. So there needs to be an arrow like that. Okay. All right, it's still red for some reason. Did I call the wrong function? No, was default value. Okay, we're asking for the key. Called, I guess in the beginning it's false, and over here we're setting it to true, and create a map key value. What's default value? Default value. Oh yeah, I'm stupid. So we're using the default value actually over here, right? So that's kind of not cool. Okay, so the trick to solve this is to convert this cold into cold times, right? And it's going to become an integer now. Cold times is going to become an integer, and in the beginning it's going to be 0, right? And every time we call it, we're just going to add 1 to it, plus equals 1, and then it should become 1 over here, right? But it should not become 2. So we're going to say cold times should be 1, and that's going to fix it. Somehow I missed that when I was writing the script. In any case, let's just continue. Another very common mistake is happening if you accidentally call withDefault, and occasionally it will actually compile. Check this out. So let me create a bit more space. In fact, we actually don't need that much space over here. Let's do it like that. All right. So let's just say test. Just call it hello world. All right. So let's create a map over here, which is going to be a map from int. Okay, hold on. Map.empty int string. All right. So what we're going to do is we're going to say withDefault instead of withDefault value, and we're going to give it a string like hello, right? And what's going to happen is that first of all, it's going to compile. So let me just save it, and you will see that it compiles. There we go. It compiles. So what's happening is that a string is actually a function. Right? So if we have a function from int to string, which is exactly what withDefault wants, then you can pass it a hello, right? So what will happen is that f is a function of, int to character, right? So a string is also a sequence of characters, and it has an apply function where you can pass in the integer, which is going to be the index, and so it's going to retrieve the character at that index, right? So if I just say, okay, f of 0, which is the index 0, it's going to be, it should be the character h, and f of 1, it's going to be e, and so on and so on and so on, right? So this is actually what's happening. So be very careful with with calling the proper function, right? Well, you have a statically typed language, but still sometimes accidents like this happen, right? So let's continue. And the next thing that we're going to do is going to be a very cool test actually. So this test is going to make sure that you actually can call withDefault multiple times, right? Because nothing prevents you from doing that. Override the previous default. Okay, so withDefault should override the previous default. Because what's happening right now is that if you have a map, let's have a map over here. I'm going to have map, empty, int, and string. Okay, so if you call withDefault value like this, right? And we're going to say first, and then you call it again, and you do second. The problem is that over here, we're sort of destroying the value of function, right? So the value of function will already say, okay, if there is no key, I'm going to return first. And then if you do that, it's going to say, okay, if there's no key, I'm going to return first. And then if there is no first, I'm going to return second, but there is a first, right? We already overrode it, right? So let's finish writing the test. So we're going to have a map of some random int like this, and it should be some second, but it's not going to be some second, it's going to be some first, as I just explained it. And in order to solve that, we're actually going to go back. So we're going to ignore this test first, and we need to do a lot of refactoring, and this refactoring is going to help us to introduce this change in a more controlled manner. So the idea is going to be to also keep track of the value of and the default value and the default. So the idea is to keep track of the value of and the default functions, right? The two functions, to keep track of them separately instead of letting one sort of being mixed into the other, right? I don't have better words to explain it. So at the very top, our map, as I said, is a set of keys and this function. So what we're going to do is we're going to also keep track of this other function, default, right? So we're going to give it a key, and we're going to produce a value. Now the thing is that our users, they might not even call withDefault on our map, so they shouldn't be forced to pass in this function. So let's make it optional, right? So this function might be there, or it might not be there. So we're going to go down actually to the companion object, because in the companion object we also have a helper to create the map, which is over here. Right, we're going to go over here and we're going to do it like that, and we're going to just pass it over like this. And now we're going to go to the empty function, right, which is this one, and we're going to say that in the default case, the default is going to be none. Now we need to go to the add function over here. We need to say, okay, key is going to be this, value of is going to be this, and the default is going to be the default. And we need to do the same thing in the remove function, right? So we just, we're just passing them through. Nothing major, right? So let's try to save it. It's probably not going to compile somewhere. Okay, map 99, which is 99. Yeah, so this is exactly where we want to be. So now instead of doing this complicated thing, we're just going to pass value of through, and the default is going to be the new default, right? Right, so we're just gonna wrap it into option, and that code that was over here is gonna travel all the way up to apply, right? So if we're gonna go to apply, so we're just gonna say, okay, so instead of just getting the value of key, and if the key is not there, we're gonna return a none. We're just gonna do or else, and we're gonna do the same thing as we did before, but remember that now our function is inside of an option. So I'm gonna have default map, right? So if the function is there, we're just gonna apply it to the key, right? And that's pretty much it. Actually, that should already be fine. And if we go back to our test, it turns out that it will start running it, that we're actually already done, which is really cool. So usually you would go back, you would ignore the test, you would do the refactoring, because remember, you can only refactor when you test the green, right? And you do the refactoring, and then you go back for the test, and only then you add some changes. But in this case, we didn't actually need to add any changes. And note that we have both apply and value of now, and in the past they were doing the same thing, so it wasn't, it didn't really matter if inside of the map we're calling value of or apply. Now we actually have to pay attention to which one we're calling, and I'm going to show you an example of this in just a few minutes. Okay, what we're going to do now is we're actually going to add a helper function, because in a few times, for example in add and remove, we're just passing the default through, and over here in the actual default, we're passing keys and values through. So what we're going to do is, our map is not a case class, right? It's just a regular class, because we want to have the constructor private. So what we're going to do is we're going to create the copy function, the one that is usually generated for case classes. Remember the video about case classes. So we're just going to generate it manually, right? So we're going to have a private disk final def copy, and it's going to have this covariance dance, right? So it's going to have a keys, which is a set of key, right? Key like this. Okay, so this basically, it looks basically exactly the same as the constructor. It's going to have value of, and maybe we even should copy that. Let's copy that like this, and where's our copy? Over there. Paste it in over here. Whoops. Paste it in. Whoops, come on, I want one cursor. Paste it in like this. Okay, so now we just need to pass in the defaults. The default is keys, the default is value of, and the default is, well, default. Okay, and all it will do is it will create a map of key and, come on, key and super value. Okay, and it will just equal to map of keys, value of, and default, right? So now we have this fancy copy method. I'm going to let Scalariform do its job. And now we go to a few places and fix them. So we're going to go to withDefault. Instead of just creating a map, so we're just going to call copy, right? And then we don't need to specify the keys. We don't need to specify the value of. All we're specifying is this default. And now I believe we don't actually need this formatting trick over here like this. And actually, I kind of prefer to have that over here. So if we look at it like this, it looks kind of beautiful. In fact, what the hell, let's just do that. Okay, and let's also go to add Okay, what's happening? Some default. Error occurred in application of default argument. Found key to super value required key value. What's happening is that when I was copying them from over here, I forgot that over here we actually need to use this super value, and over here as well. Super value. There we go. Okay, so now it should be fine. Now we just need to go to add, and instead of creating a new map by calling the factory, we're just going to call copy instead. And we still need this, we still need this. Now we just don't need that. So it's basically reverting to what it was before. Same thing over here, copy, no default over here, right? Technically, even at the bottom over here, can we? No, we can't. All right, so this is actually all the refactoring that we needed to do. All right, so next the next thing that we're going to do is going to add yet another common function called getOrElseUpdated, and we're going to add a test for it. So what getOrElseUpdated is doing is it basically says, okay, give me that key, give me the value for that key, but if it's not there, then add a value for that key and give it back to me. Now, because it's immutable, the map is immutable, it's going to give you a tuple back. It's going to give you a tuple with this, new value, right? And it's going to give you the newly created map. So we're going to have getOrElseUpdated. getOrElseUpdated should use a by name parameter for their new value. All right, so I'm sort of mixing like two tests in one because I know that we're going to have quite a few tests for this. So we're going to do this cold thing, cold equals false, and we're going to have a lazy val new value. It's going to do this trick, cold is true, new value. It's sort of similar to the default value. All right, so we're going to have a random int. We're going to have a value of random string. We're going to have a map, which is a map with only one element, key value. All right. So now what we're doing is we're taking this map, right? We're calling the getOrElseUpdated, and we're passing it the key, and we're telling it what to do if the key is not there. And we're going to say, okay, if the key is not there, then add the new value to that map. Well, I'm saying to that map, but everything is immutable, so it's actually going to create an entire new map, right? So it should give you a tuple back with this value, right? And with this map. So in this case, the value was actually there. So it should return you exactly the same map and exactly the same value. So basically it should ignore the new value, which is why we're writing this test. And we're testing at the same time that the new value should be a by name parameter. So the call should be false in the very end. So this is exactly what we're testing. We're going over here, we're saying cold should be false. Now, obviously, the test is going to fail because it's not even going to compile. All right, getOrElseUpdated is not there. So let's go over here under this prep. Let's have this copy at the very bottom over here. So let's start adding it, and we're just going to start adding it with the signature. So it's going to be getOrElseUpdated, the same covariance stance over here, value. Okay, so now it's going to get the key. It's going to get the new value. Which is going to be a by name parameter. We're going to do it right away just to save some time. Super value like this, okay? And what it gives back is a tuple, right? A tuple of super value and a map, that was supposed to be a comma, and a map of key and super value equals, throw some exception. Let's just make sure that at least it compiles, and it looks like it does. I'm going to create some more space over here. All right, so one test failed. Okay, so what we're going to do is we're going to call apply. And remember I told you that there is a difference between apply and value off, but in the beginning we're going to do apply because we don't have a test that yet. So we're going to call apply, right? And then we're going to have a map over here, map. This is actually the entire implementation, right? And then we're going to say getOrElse question marks, right? So this should be enough to pass our test. So basically what it's doing is says, okay, let's see if we have the value. And if we have the value, then let's just return it, right? So it's basically saying, okay, let's just return the value and the current map, right? So it just return this tuple. Remember, this is just a syntactic sugar, right? Otherwise, if it's not there, then we're going to do something else. But before we do something else, we're going to add a test for, for requesting this functionality. Okay. Shit, I'm losing my voice again. All right. So we're going to add the test, and the test is going to say test getOrElseUpdated should yield. That's not how you spell yield. Should yield a new map if the value is not present for the key. Okay. So we're going to have a key over here. Let me scroll down a little bit like like this. The key is going to be random int, and we're going to have a new value, which is going to be a random string, and we're going to have a map, which is going to be empty, int and string, and we're going to have a getOrElseUpdated, and we're going to have the key, and we're going to have the new value. And this time it should be this new value, right? So we used to have value and the map that we had before, but now it should give you a new value and an entirely new map. So it's going to give you the map with the key and this new value. And obviously it's going to fail in the beginning because we don't have the implementation. So also spelling is not so easy these days for some reason. All right, so we're going to go back to getOrElse, and our implementation is going to be very, very simple, right? So in the getOrElse case, we need to return a tuple with this new value, right, which is over there, new value over here by name parameter, new value, and we're going to return a different map which contains this value, right? So we're going to say add, so it's basically this dot add for this key, the value should be new value, and that's pretty much the entire implementation. Was there's just a few things that we need to change. So the next test that we're going to add is going to be the by name parameter should be called only once, right? getOrElseUpdated should call the by name parameter at most once. So we're being very, very what's the word? Very, very professional with tests today. So we're testing really every corner case. So we're going to have times cold equals 0. How did I call it before? Did I call it something different? Cold times. All right, so cold times is going to be times cold now. All right, so times cold is going to be 0, and we're going to have the def new value. It's going to be a def, right? So I'm going to go times cold. Oh, by the way, it has to be a def. Hold up, I just remembered something. In the beginning, in that test, where we have the times cold, it can't be a lazy val, because if it's a lazy val, then this code will run only once anyway, and our test doesn't actually test anything. So it needs to be a def, and hopefully it's going to be still green. Yeah, it is still green. Okay, cool. So let's go back to this one. Okay, so it has to be a def. All right, so we're going to return a new value over here. All right, and we're going to go down. We're going to have an empty map. Okay, it was an int. Whoops, what happened there? It was an int and a string, and we're going to have a getOrElseUpdated. Okay, it's going to return a random int and a new value. Okay, so basically this map doesn't have any keys, so it should call the new value. And now times cold should be 1. There's no need to test that what comes back over here, right? So let's save it. All right, so there are two ways we can implement this. The first one is by going over here, having braces over here, right, and having a lazy val. And let's call it value, and it's going to be new value, right? So we're basically making sure exactly what our test is specifying. It says getOrElseUpdated should call the by name parameter at most once, and this lazy val is going to make sure that it's being called at most once. So now instead of using new value over here, we're just going to use value and value like this, right? And this already fixes it, but I don't like the fact that we have the curly braces, and also I don't like the cohesion here. I want the value to be as close to the code that is actually using it. So instead we're going to use curly braces over here, right, like this. We're just going to bring it down, so now it's closer, and because it's closer, we actually don't need those curly braces. Well, not because it's closer, right? We don't need those curly braces, and now it's doing exactly the same thing, but it's close. And in fact, if you look at this code is only running in the getOrElse case, so we actually don't need the lazy over here, which is better. You know, the less features you use, the better. The very last thing that we're going to do for the getOrElseUpdated is we're going to make sure that it calls value off instead of apply over here, right? And we're going to make sure by going to, I think, this one. In fact, to this one at the bottom, we're going to go to getOrElseUpdated. So this one tests that it should yield a new map if the value is not present. But if we do a withDefault value, right, then it wouldn't be able to figure out that the value is not present, right, because it's calling apply. So we call withDefault value. Doesn't matter, right? It just matters that we have the withDefault value, right? So it's an entirely new map. So as I said, our method getOrElseUpdated is not capable of recognizing that the value is not there, because it's calling apply, which gives you an option which does or else, and it always gives you this default value. So all we need to do is to make sure that we call value off. Like technically, we should go to all the other methods and write tests for them to make sure that they all call value off instead of apply. So apply is only like for public people, it's only the public API, so it's only for the users. But let's not get too crazy. Okay, the last thing that we're going to do in this video is we're going to start seeing how sats interact with maps. So we're going to go to sat suite, and we're going to write a task for sats because we're going to add a method called groupBy to sats. So the first thing that we're going to do is we're going to import sat suite over here, which is going to be the companion object that we're going to create at the very bottom. We're going to have object sat suite like this, and we're just going to create a case class called person. By the way, I'm not sure if you noticed that I'm using Sublime, and Sublime has templates for Scala. So if I just type CC and press tab, it's going to convert it. What did I press? I did not press tab. CC tab. What's happening? CC tab. There we go. Okay, this time it worked. Okay, so it generates the final case class, and I can call it person, and I can press tab, and it will jump over here. I can say name, string, age, and if I press tab again, it will jump over here because it's things that maybe will add more functionality. All right, so the test that we want to write is going to be like, it's going to look like this. So it's going to say groupBy on an empty sat should produce an empty map. So this is the first time that we're calling something on a sat, and it doesn't produce a sat or a boolean or something simple. It actually produces a map, so it has a dependency on the map. So this one is going to say, okay, so we're calling it so we have an empty sat of integers, right? And we ask it to group by those integers by the toString implementation, right? So what it should produce is a map of these types: string and sat of int. Now remember that because of type erasure, the types actually won't be able to be verified, but still, at least it's enough to it's enough for us to add the not the body of the method, to add the declaration of the method to see the signature. Okay, so we're going to go to sat. I'm going to go to the very bottom over here. So we're going to add a final def groupBy. Right, so the groupBy with an element to key. Here's a map of key sat of element. Come on, and just throw some exception. So what groupBy does is it takes the sat, right, and it takes this function that knows how to retrieve the key from these elements, right? So it basically maps an element to the key, and it produces a map that has this, mapping of the key, and as values, it has another set of elements. It will become clear once we're going to start adding a bit more functionality. And by the way, why are our tests green? Oh, our tests are green because we're running only the tests for the maps. So let's actually run all the tests like this. And there we go. Okay, something that was red because we're throwing this exception. All right. So what we're going to do now is, instead of implementing it, we're actually going to add another test. So usually we don't do that, but we're going to do sort of like a behavior-driven development. Let's ignore this one for a bit because I just want to show you what groupBy is actually doing. Because as I always said, we started with a bad test. Bad test in the sense of we're testing the sad path of the code, but in this case it's actually not clear what it should be doing. Okay, so we're going to have a groupBy on a non-empty sat should produce a map from key to value element, right? So basically, if we have a sat of, let's say, 1, 2, 3, 4, okay, and we're calling groupBy on it, groupBy even, right? So this functionality says, okay, so if we have this, then what should come out is a map that literally groups by these numbers by the fact if they're even or not, right? So this function returns a boolean, which means that the key over here, the key is a boolean, right? So it groups them by, and it's going to say, okay, there will be something for true, and there will be something for false, okay? And for true, it's going to pick out the ones that are even, and for false, it's going to pick out the ones that are not even, like this. Now, obviously, it's not doing what it's supposed to yet. What does it say? Okay, what did I forget? Something GroupBy, that's fine, should be map. There's no comma over here. There we go. All right, ScalaReform did its job. All right, so now we can enable actually both of these tests like this, and we can add the implementation. The implementation is going to be very, very similar to the default functions, and it's going to look like that. We're starting with traversing our set by calling fold, and we're going to say, okay, what we're producing is a map of key and the set of elements, right? So this is going to be a bit complicated, but it shouldn't be like too complicated because it's very, very similar to the default functions. Okay, so if our set is empty, then we're going to produce an empty map. This is what our test before wanted. You know, the test that we ignored, this one, you should produce an empty map. Okay, you know, I could have actually added that before adding everything else. Okay, so we're going to have ACC and we're going to have current, as always, right? So this is going to be a slightly larger fold. Okay, so the first thing that we're going to do is we're going to get the key. Our key is, you know, we have our current element over here, right? So we're traversing the set. So what we need to do is we need to produce a key, right? So producing the key means calling that function. So we're calling key with the current element, right? So this is how we get the key, okay? And then we're going to go to the value, and the value is going to be a set of elements, right? So this is our key, and this is our value, okay? Set of elements, okay? So the way it's implemented is we're accumulating here a map. Right, so this ACC has this type. It's a map of keys to set of elements. So let's see if it has a value for that key. The value is a set, right? This is the value. So the type of this expression is a map. I'm sorry, it's a set of element, right? Maybe I should leave it like this actually. Okay, so this is a set of element, and if it is there, then we're just going to add to this set the current value, right? So this is, you know, this is what we did. Okay, and if it's not there, we're going to create an entirely new set with this element, right? So if there's already some set, we just add a value. If there is no set yet, we create an entirely new set. Okay, and now all we need to do at the very, very end to this thing that we're accumulating, we just need to add this new tuple, key value, and that's it. Let me remove that, like that. There we go. I didn't do any mistakes, everything is green, it's all good. So what I'm going to do now is I'm going to add just a few more things to the test so that it becomes clear why this method is so useful. All right, so let's go to our tests over here. Because remember when we switched to the set suite, I added this case class person. So this is exactly why I added it, because I wanted to add a task for the group by. So we're going to have Alice with the age of 27. And we're going to have Bob over here. Bob is going to be 25. I'm going to go duplicate Alice because everybody else is going to be 27. So I'm going to have Carol, and we're also going to have Daniel. All right. So now what we can do is we can go and say, okay, so people who are X years old equals. So we're going to have a set, right, with all of these people: Alice, Bob. Come on. Bob, Carol, and oh man, what happened? Carol and Daniel. Okay, so we're going to go here and I'm going to say, okay, group by age, right? So this is a very, very common pattern. So you have some sort of case class, you have a set of them, right? And you just group them by age. And what you also can do is you can say with default value set that empty. So basically this way there will be never a none returned from this map. Okay, so you just have this map, right? And now what you can do is you can write the test by saying people, what, no, not this. People who are X years old should be, right? So it literally grouped them by age, right? So it said, okay, the people who are 25 is just Bob, right? This one, okay? And the people who are 27 is everyone else, right? So it's the set of Alice, Bob, and Carol. Okay, and also, you know, this is a function, right? So you can go to people who are, whoa, what happened? Oh yeah, I'm silly. It's actually Alice, Carol, and Daniel. All right, I shouldn't record videos when I'm sick. All right, so it's also a function, right? So we can just go to here and say 10. So people who are 10 years old should be some set of empty, right? Because we said with default value set of empty. If we hadn't done that, then this line would be none. Okay, and we go to that thing with 25, and it should be you know, we're just playing at this point, right? Set of Bob, and 27 is Alice. Let's see if I make the mistake again. Carol, Daniel, like this, right? And for instance, if you wanted to figure out like how many, you know, how many people are 25, how many people are 27, then you could go down over here and you could do people who are X years old, map, and you have the key value over here, right? Key value equals age, oops, people dot size, right? So we're creating an entirely new map, okay? And we're saying it should be a map of, all right, how many people do we have that are 25 years old? 1. How many people do we have that are 27 years old? We have 3, right? And because this is such a common thing, you know, unless I made a mistake, and of course I did. Why did I call it key value? It's age and people. There we go. All right, so because this is such a common thing, let's actually go to our maps and add a function called map values that will do exactly that. So we're going to have a final def map values, which will take some new value as a type parameter. It will get the function that takes the value, produces the new value, and it's going to be map of key new value equals map of, it's basically doing exactly the same thing as we just did, right? So key value, and now it's going to keep the key alone, and it's going to apply the function to the value like this. And now, oh yeah, I'm adding this to the set. Why am I adding this to the set? Let's cut this out, go back to the map, and go over here. Let's say over here. Map values. There we go. All right. So now we can go over here, and instead of doing this whole thing, I'm gonna copy that. I'm gonna paste that over here. I'm gonna say map values, and I'm just gonna map the values to size, and that's all. So this entire thing goes away like that. Maybe I should do it like this. Map values, yeah, like that. I think like that. It's prettier. Yeah, there we go. It's exactly the same functionality. And the very last thing that we're going to do in this video, which was supposed to be super small, but somehow it ended being so super long, we need to realize that sets are foldable and maps are foldable. And in the implementation of groupBy, all we're using is fold, right? So this means that we can just cut this thing out, go to foldable, literally paste this thing in without any changes, and it should work just fine. The only thing that you need to realize here is that let's say that we have a list in the future, and the list will extend foldable. And if you have a list of 1 to 3 and you group them by, you know, by this even thing that you know that we did over here, over here, right? Let me create some more space over here. Right, so let's say we did something like this was a list. What would come back is still a map and the set, right? It might be sort of surprising to get this back instead of the list. We could also implement it in such a way that the list would come back, but then we wouldn't be able to add the group by to foldable. We would need to add it to the foldable factory, and I really didn't want to do that. All right, so that's pretty much everything that I wanted to do today. So all that is left to do is to go into a different tab and to say git status. Let's see what we did. We didn't really add any files, but let's still do that. Git commit -am, and it's video 22. And I'm just going to say typical map operations. As you might know, that I don't really know how I'm going to call the videos, you know, once, you know, at the moment of recording. Okay, so let's push that. Let's unlock my key. Should be fine. All right. So now if we go to my browser, and we got the commits over here, typical map operations. Let's click on them. Let's see that real quick. And yeah, so we added groupBy to foldable. We changed the map a little bit. We added this withDefault thing. We added the copy thing, and getOrElseUpdated thing, map values. And that's pretty much all that we did. Everything else was just adding the test. And that's all I got for you today. I'm sorry for my voice because I'm still a little bit sick. And yeah, it's been Blab, Untitled.com. Don't forget to like this video if you did. Subscribe if you want to improve the developer inside you. And most importantly, Take care.